Hello, we're going to take notes over lesson 1.2. So make sure that you either have this printed out or you are copying this in your notebook. So this again is lesson 1.2. We're going to talk about properties of real numbers. Most of these you should have seen or heard about before now, but I'm going to review them with you and we will use them quite a bit, especially when we start solving our equations and so on. All right, so I'm going to jump right in so I don't waste your time. First one, commutative property. This is the order when order does not matter. So what I mean by that, if we're talking about addition, whether I say like A plus B is the same as saying B plus A. If I show you that with numbers, for example, 2 plus 3, I would get the same answer if I did 3 plus 2. So the order doesn't matter. That's addition. The same thing's true of multiplication. If I do 5 times 4, that's going to be the same thing as 4 times 5. They're both going to get me the answer of 20. And so that is your commutative property, okay? When order doesn't matter. That only works for addition and multiplication. The next one, associative property, is the grouping of values does not matter. Now again, this one only works for addition or multiplication. So if I do, I can write this, 5 plus 1 and then plus 3 on the outside, I'm going to get the same answer as had I done 5 plus 1 plus 3. So see how I move the parentheses? So on the left side, 5 plus 1 is 6, plus 3 is 9. On the right side, 1 plus 3 is 4, then plus 5, but it's still 9. It does not change. Same thing for multiplication. If I were to multiply in parentheses A times B times C on the outside, I would get the same answer as if I did A times, and then in parentheses, B times C. And if you want to follow this up with numbers, just to double check, so 2 times 4 times 7. Okay, that should be the same answer as if I had done 2 times 4 times 7. So if we double check, in the first side, 2 times 4 is in parentheses, so I solve that first. 2 times 4 is 8, times 7, 56. On this side, if I do parentheses first, 4 times 7 is 28. 28 times 2 gives me 56. It's the same answer. All right, identity property, we're moving right along. This is when something stays, or not something, a variable stays the same. So in addition, what this is talking about is what number can I add to any number and it's not going to change it? Well, hopefully you're thinking 0, because any number, so if I do A plus 0, I'm still going to get A. 3 plus 0 is 3. Negative 100 plus 0 is still negative 100. Now, you should be asking yourself, okay, what about multiplication? What can we do in multiplication? What number can I multiply something by and it doesn't change? Well, that should be 1. Anything times 1. So if I did A times 1, that's just going to give me A. So A could be any number. 2 times 1 is 2. Negative 10 times 1, negative 10. All right? So that stays the same. Next property is the inverse property. This is when you use the opposite value of your number. So when we talk about opposites, we're talking about positive and negative. Okay? So for addition, you're just going to take whatever number you have, and it would be A plus negative A, and that would equal 0. They're going to cancel out. Okay? It's the opposite value to cancel out. So like 2 plus negative 2. Think about this. You have $2 and your friends borrow $2 from you. Now if you give that money to your friend because they need it, now you are left with 0 money. Okay? That's not good. With multiplication, in order to multiply something, you have to use the reciprocals. Like let's say we have the whole number 3. The reciprocal is when you multiply it, maybe write this a little better, 3 times, you would do 1 over 3. When you multiply a number times its reciprocal, that equals 1. Okay, you are canceling it out. And when multiplication, 1 is like when you cancel things out, not 0. Okay? All right. Now we're to the 0 property. This is the easiest one, should be everybody's favorite. If you multiply any number by 0, you're going to get 0 as your answer. 17 times 0 is 0. B times 0 is, 0. You can do a negative. Negative 2 times 0 is still 0. All right. The last one here, distributive property. Whoops. Let's do a different color. Let's go back to blue. Distributive property, that is where you multiply a value on the outside times all the expression that's on the inside of the parentheses. So we'll do an easy one here. If I do 2 times x plus 7, so now I'm going to take 2 times x. That's going to give me a 2x. Then you're going to come back and distribute the 2 to the next term. That's 2 times 7. And so that's going to give me plus 14. Okay, that is your distributive property. Let me switch to the back side here. All right, so those first properties you should be pretty familiar with. I'm going to show you 3 new or somewhat new probably. First, the reflexive property. This is when a value, so some number, value, expression, is equal to itself. Okay, and so an example of this, like 16 is equal to 16 all the time, never changes. 2y would be equal to 2y. That's your reflexive property. If we look at the symmetric property, it says this. If you know that A equals B, then you can say that B equals A. That's the same thing, whether it's frontwards or backwards, how you write it, that is symmetric property. It's always the same. So an example would be, if I wrote x equals 3, that's the same thing as saying 3 equals x. Okay, you can just flip it around. Or 5x is equal to 30, that would be the same as 30 is equal to 5x. So when we start solving algebra equations, it really doesn't matter what side of the equation the x is on, okay? All right, and the last one, transitive property. If A equals B, okay, and then B equals C, then what we can say, so if A equals B and B equals C, so see how they both have a B? Then we can just take out the B and say that A equals C. So let me explain this one. So we know that A is equal to B. Then that same B is equal to C. So A and C are both equal to the same value, therefore they have to be equal to each other. Hopefully that makes sense. If I show you an example over here, let's say I know that 4 plus 3 is 7, and I also know that 7 is equal to the square root of 49 because it's a perfect square. So see how 4 plus 3 is equal to 7, and I know 7 is equal to the square root of 49. I can just remove the things they have in common and say 4 plus 3 is equal to the square root of 49. 4 plus 3 is 7, and I know that the square root of 49 is also 7. All right? We are almost done. Last part. A closure property. This means, and you can read it there, like a set is closed if this happens, or if not, then it's not closed. In order to be closed, if I add, subtract, multiply, whatever operation I'm asking, the same type of numbers, so remember we just talked about the real number system, if I get that same type of answer, then it's a closed set. Okay? So if the operation, if I'm adding two integers and I get an integer answer, that would be considered closed. If I am adding two integers and I do not get an integer number, that would be not closed. So that kind of takes us into number 1. Integers are closed under multiplication. So if I multiply an integer times an integer, I'm going to get an answer that is integer. That is true. Okay, it is closed. Number 2, natural numbers are closed under subtraction. So you need to think back from your notes the day before. What are natural numbers? Those are like your counting numbers. And so under subtraction, I could do 5 minus 9. 5 and 9 are both counting numbers. When I subtract 5 minus 9, that gives me a negative 4. So now here I have a problem because natural numbers are not the negative numbers. And so this one would be false. It is not closed. Number 3, even numbers are closed under addition. So if I take two even numbers and add them together, so 2 plus 4, does it always equal an even number? So 2 plus 4 is 6. 8 plus 10 is 18. 20 plus 22 is 42. This is always true. Okay, if you take two even numbers and add them together, you're going to get an even number as your answer. All right, almost done. Irrational numbers. An irrational number, let's do an easy one. Everyone should remember pi. If I do pi and we're dividing, so pi divided by itself. What happens when you divide a number by itself? Hopefully you remember it equals 1. Well, we're talking about irrational numbers, but 1 is very much rational, so this would be a false statement. And then the last one, perfect squares are closed under subtraction. So now we have to subtract perfect squares. So a perfect square, that's 25. If you take the square root of 25, it's equal to 5. That's what makes something a perfect square. And then 4 also is. Excuse me. If I do 25 minus 4, that's going to give me 21. Now here's where the problem comes in. 21 is not a perfect square. And so we would have to say that this is false. It is not a closed set. Okay? So this concludes your notes. Make sure you have these copied down or printed out and copied. And then come to class ready to do some work. And then I also hope that you answer the flip grid question to let me know that you watched this, okay? So have a great night, and I will see everyone tomorrow.